Hello, everyone. My name is Kyle Knobloch. I'm the Vice President of Events here at the Carleton AI Society. I just wanted to introduce everyone that's going to be at this workshop today. This workshop's the first Kaggle competition submission, as well as like the overview of the CAIS X AI competition. So to start off, we have Darren, who will be introducing the CAIS X competition itself. And then after that, we'll have Amaya, who will show you guys how to submit your first notebook to the competition itself. So without further ado, here is Darren.
All right. I'm happy to be here. Hi, my name is Darren Pierre. I'm a former cognitive science student, and I'm a computer science student who's in his last year. First, I would like to give a shout out to our admin team and our tech team. They put in a lot of work to able to run this workshop and for the up and coming workshops. So I'm so great to work with them and a lot of amazing people. So let's get started. So I'm guessing what you guys thinking is what is CAIS X? And what is CAIS X? It's pretty much a Kaggle competition open to Carleton University students for them to practice and learn more about data science and machine learning. So this year, unfortunately, we're all been affected by the pandemic that's going around the world. So why not kind of use it to our advantage and see where data science and machine learning can be applied to this kind of use case. So for this competition, it's a multivariate time series forecasting competition. And what that means, you'll be using multiple variables to try to predict multiple other variables. So in this case, it'll be the amount of deaths, the amount of recoveries, and the amount of cases. So pretty much the competition starts pretty much right now today. And you can just go and enter the competition through carletonai.com/x, and you'll be able to see the Kaggle competition. So I'm here to answer any of your questions. So pretty much, in terms of the real world impact, definitely it has tremendous real world impact because it can help kind of guide to kind of policymakers or political leaders of decision what they should make. So potentially, as of right now, we see an upward surge in terms of cases. So definitely, using kind of this model, they can kind of judge what they should do, whether if we should go on a lockdown or not, and see if we do not take action, what will potentially a future cases in the upcoming days, weeks, or months may look like. So the competition will end on November 25th, and then the next day, the top three winners will be able to present on the following Sunday about what their solution, what they kind of found interesting, and their models, and they'll be presenting to us, the case executives, and to the sponsors, and to you guys. So we hope that you guys learn something out of this, and I'm here to answer all your questions. No questions? No questions? So I think I'll just go gloss over the rules. So one of the rules is that you can't create multiple accounts in order to like enter the competition because obviously it's kind of cheating where you like have multiple accounts just to submit like more and more entries. Um, so only one account for like one individual. So you can either work by yourself or with another person. So up to teams of two max. What else? So the terms of using external data sources, it's very encouraged that you guys go out and try to look for potential other data sources that could aid in your models. But one thing we ask is that you don't use data that directly the thing that you're trying to predict, such as the cases, the recoveries, and the deaths. So you can't just be like, for this province at this date, what is the case for at this time, or the recoveries and deaths. But you're free to use any other data sources. And then in terms of the open source software, you guys can use anything from Google to sklearn to kind of using a neural network library, and Yeah. So we will, since this is our first year kind of doing this, we may not see potential rules may change because we it's our kind of our first hack at it. So we're definitely on a need to be basis, and we'll definitely let you guys know when we change the rules. Um, and yeah, that's pretty much it. So if you guys have any questions, feel free to ask me. If not, Amaya will go on to present.
Okay, sweet. Thank you, Darren, for the introduction. I'll just start off by introducing myself. My name is Amaya, and I'm a third-year computer science student. I'm currently a project coordinator for the AI Society, and yeah, so today we're going to be doing, basically I'm going to walk you through a Kaggle competition, just what all the tabs are, and then we will be creating a basic model, and then I'll just show you how to submit that model, and yeah, that's about it. So we start out with the overview tab, and the overview tab is basically what Darren just said. It's just like an introduction of what the competition is, what's the purpose of it, everything like that. It started today, and it ends on November 25th. You have 5 entries per day, and yeah. So then there's the evaluation tab after that. And this is basically just the way that it's going to measure your predictions. So like this year we're doing the root mean squared logarithmic error. And so, yeah. And then the submission format is actually very important to make note of this. This is the way that they want you to have your submission and your predictions to look when you hand it into the competition. So you're going to have a forecast ID, the number of deaths, confirmed cases, and the number of recovered cases. And then we'll move on to the data tab. The data tab basically shows you all the files that you're going to be given for the competition. So you have the trained CSV, which is basically just going to be your training set. These are all the data fields that are going to be within the training set. This is really important to get familiar with because you just want to know your information and your data when you're working with it. So that you can make like good predictions. And then we have the test CSV, which is the test set that you use at the end. And then there's a sample submission file. This is the way that you want it to look when you're going to be submitting your predictions to the competition. If it doesn't look like this, you might run into some problems and mistakes. So this is kind of what you want it to look like with the forecast ID and all that stuff. This is the test CSVs and stuff like that, and you can look at that. The notebooks tab, this is where people can share their notebooks with you, and there was a rule about this that Darren talked about, and if you're going to be sharing your notebooks, please don't just share it in between a few people. We want it to be fair for everybody, so just make sure if you're going to be sharing, you share with everybody. And then any of the notebooks that you have created for the competition will show up here. If anybody shares with you, stuff like that. There's a discussion board that's kind of like a forum. If you have any questions or any tips for other people that you'd like to share, this is a good place to put it. You can also use our Discord. And then the leaderboard. The leaderboard is basically going to show you like what place you're in compared to the competition and everything like that. I'm pretty sure Chris talked about that in the last one. And then the rules that Darren talked about. Maximum team size is teams of 2. So if you wanted to create a team, you'll come to this tab and you'll have your team name up here, and that's how you'll kind of like identify other people as well. If you want to merge teams, you'll just type in their team name and then request a merge, and all your requests will show up here. And if anybody wants to merge with you, it will show up there as well. If you want to see all the submissions, it'll just show up here. And yeah, so let's get started on creating the notebook. I'll just go to here. Okay. Once this loads. There we go. Okay, so we're basically just going to build a basic model for predicting COVID-19 cases. It's just a great way for to get you guys started, and like if you're a little confused on what exactly you should do, this is just kind of to get you used to everything. All your inputs will be on the side. So like I said in the data tab, you have your submission CSV, the test CSV, and the train CSV. These are all important. And so, yeah, the first step to building a basic model is you're going to want to import all your data and libraries. So some important libraries, as Chris mentioned in the last one, is NumPy, Pandas, Matplotlib, and sklearn. And to read in the data, you're going to want to make a variable for train and test, and you're going to just want to find the file path for that. And the easiest way to do that is just copy the file path. So you go over to the right side to the input, and then copy the file path and just like paste it in there, and it'll be good. Once you have your file paths, you can create your data frame, and this is, you're going to want to use Pandas for this. They have a function called read CSV, and you just throw in your file path that you found, and it'll make the data frame. And a data frame is essentially just like a table, and it's a lot easier for the computer to read and analyze when you're creating your model. So it's going to have all the columns of the information that you have, and then each entry below. I'll show it later in the presentation. You can skip this whole step with the variables, but it just looks a lot neater. So yeah. Visualizing the data. It's really important to visualize your data because that's one way to understand the information that you're working with. It's also really good in the future for when you want to do like feature engineering, which we're going to be talking about, I think on the 25th of October. So yeah, sorry, I just have to. Okay, so we'll start by just looking at the shape of the data frame that we're given. And this will just tell us how many records that we're working with. So as we see here, there's 2,460 records, so like entries in the like rows along 12 columns, or 11 columns, I guess now. And so that basically just says we have 11 attributes that we're working with and 2,460 entries. And if we want to take a look at what this data looks like, this is kind of what it is. .head just grabs the first few entries in the data frame. And so this is the information. We have all the things that we saw in the data tab. We have confirmed cases, deaths, recovered, all that stuff. And if we want to see the very end, we have that. And it's kind of nice to see the head and the tail of the data frame because you can see the start date, which is February 12th. And the end date, which is August 5th. So, yeah. Another important thing is you want to look at the data types that you're going to be working with for the competition. And so this just helps you create like better estimates and stuff like that. So if you look here, we have the date, and it's an object, which kind of it's going to be read as a string because if you look up here, it's just like that. And objects in Python can also be strings. And we don't necessarily want to do that because it can sometimes get messy, especially when we're reading it in. We want something that will be a little bit more reliable when we're training our model. And so luckily there's a handy module called the datetime, which will turn regular objects and strings into date type objects. And the way that we do that is right here. So we take the date column, and then we use pandas to datetime, and then you take the date column again, and you specify the format that it's currently in, so that it can take the format and turn it into the date object. So right now we have the year, dash month, dash day, and you see that that will correlate with here. You want to do this for your training data frame and as well as your test data frame, because everything that you do to your training data frame, you want to do to your test data frame because you want it to be even. And so when you run it, like it'll match up. So now if we look, oh, should run that. Sorry. Okay, so now we see that the date time is date, and we can move on. So now that we have all of that figured out, we can now plot some of the information so that we can visually see just how everything looks. And first, we're going to start by looking at confirmed cases by date and province. There's this handy thing called group by, and this basically just takes the date and it groups everything together by the date. And then we take the second attribute, which is province. And so for every date, it's going to group it by province and record the number of confirmed cases. Then here you just set the axis to whatever you want to name it. And that's basically what it's going to look like. And we can see here visually just the amount of like the number of cases and how it just peaks up and then the curve kind of drops a little bit. Yeah, and so we can do that for deaths as well, where we group by date and province and then the number of deaths. And so it goes all the way up, and it's not as high as cases, obviously, you'd hope so. And yeah, it just kind of like plateaus after, which is nice. Then we can do it, because these look a little bit jagged, if we want to like round it out a bit and make it easier to look at, we can add this rolling 7. And so that just takes it like by the date and groups it into like groups of 7, so weekly. And it kind of just makes a nicer rounding looking graph. And so yeah, we can do that for deaths as well. And that's kind of what it looks like. And it's easier to just understand the data and see what we're working with. And then we move on to pre-processing. And data pre-processing is a super important step in the machine learning because the quality of the data and the useful information that can be derived from it directly affects the ability for our model to learn. We're only really going to focus on like basic pre-processing, so like handling null values and creating training and validation sets. But some other forms of pre-processing include standardization, one-hot encoding, and identifying outliers. And one thing that you can do outside of this workshop for one-hot encoding is we have provinces. I don't actually take that into account in this workshop, but if you wanted to take a look at that, one-hot encoding basically turns categorical data into like, sort of to be able to work with like make it numerical a little bit. It's really confusing, but we'll talk about it in a later workshop. So first we'll handle null values. And as we saw earlier, we had a lot of like this null value stuff here. We don't necessarily want that, but we need to understand what the data is saying before we actually work with them. So if we look here, it's all the way back in February 12th actually. And so because this is null, we can probably assume that it's just because it's the beginning of COVID when things haven't been actually like set in place and then we haven't had many cases and stuff like that. So we don't want to get rid of that data because it's still important. So instead, we should probably like fill the null data with zeros because we know that these probably aren't going to be numbers because we didn't have that many cases back in February. So right here, I am basically just filling in all the null data with zeros. So fill NA with 0. And I'm going to do this for the test data as well because we want to keep it matching. And then, yeah, so you'll see here that it also just turns everything to 0. And so that now that we've accounted for the null values, something that you may have noticed is that the date attribute is very different than the rest of the other data. An easier and more straightforward approach would probably be to do like by the day of year instead of by the date. So like instead of 2020, the month, and then the day, you just have the day of year. So January 1st is 0 or 1, and then so on from there. A way to fix this is to just make a new column called day in our data frame, and grab the date column, and then just apply this like lambda expression to make it a day of the year. The day of the year is like a method that you can use. And so yeah, if we just print that out, then we'll see that all of that stuff turns into the days of the year, which is kind of nice. Okay, so then we'll move on to splitting the data, which is handling generalization and overfitting. Generalization is a term used to describe a model's ability to react to new data. That is, after being trained on a training set, a model can digest new data and make accurate predictions. A model's ability to generalize is central to the success of a model. If you train a model too well on your data training set, that's called overfitting. So if we look over here, if you train it too well, it's just so familiar with the data that it's going to just try to hit every single point. We don't exactly want that, because although it looks really good and it'll make accurate predictions on that set, for others it won't make as accurate predictions. We want something more balanced, something that will go along with the flow of like most data instead of just that particular training data set. A good way to avoid overfitting your data is to split your training data into two subsets, a training set and a validation set. And training sets are basically just a sample of data used to fit the model. That's what you want to train it to. And then your validation set is the unbiased sample that you're going to use after you fit it, just to train your model and see, oh, how well your predictions are on that one. Then you have the test data set, which we've been given. This is the final test to basically evaluate the performance of your model once it's been trained. Yeah, and so the way that we're going to basically be making the validation sets is to split the training sets by dates. And the reason that we're doing this, because there's other methods of splitting your data, but it doesn't work as well when you're working with dates. You have the split date. So we're going to choose a time of year. That's roughly 20% of the data set. So since we started February 12th, I tried to take 20% of the days, which is basically roughly around like March 19th. So I grab that date, which is our split date, and then I make a new data frame basically called split. And so I'm going to take all the dates that are less than or like before March 19th. And then we want our validation set to be every date before March 19th, and then all the training sets to be after March 19th. So if you see here, the validation set goes from, this is the end of it, sorry, but it ends at March 18th, which is exactly what we wanted to. And then we look at the train tail, which is at the very end of our actual data set. So now that we've done most of the pre-processing, we want to actually implement the model. And a good implementation, like a good model that we could implement for this, is a decision tree regressor. And a decision tree basically works as like an if-else statement, just like a giant if-else statement. You have all your information here, and it just splits based on the predictions that it thinks it will be most accurate. So yeah, it goes through one decision, and if it thinks if it's true, then it'll go this way. If it's false, it'll go this way, and it'll just go down the tree until it finally reaches a decision or an accurate prediction that it thinks will be accurate enough. The model learns to map out data to outputs in what is called the training phase of model building. It takes in the data that we want it to utilize in the prediction process along with the values that we want it to predict. So here's an example, and it basically takes the height and the weight to guess the age. Okay, so we'll go through here. So now we want to select the trainable columns that we will be using as long with our target columns. So some of the targets that we want to train on are things like the day, the population, the number that's been tested, along with the longitude and latitude of where they're located. And then our target columns are the ones that we want to be predicting. So that's the number of deaths, the number of confirmed cases, and the number of recovered. And then we create our model called the decision tree regressor, and then we want to fit that model to the training set. So we take the training set and we basically want to fit the model so that it's training on all these columns and guessing all of these. So this is what we are using to predict this. Okay, and then we want to make our predictions. So now that we've fit the model, we want to train it, and so then we take our validation prediction by predicting the validation set on the trainable columns, as well as we're going to just do the train prediction as well, because that should be 0 because we've trained it with those answers and with that data. And then we also want to make the test prediction. So then we do the model.predict test data frame on the trainable columns. And since we're measuring with the mean squared log error, that's what we're going to be using here. And so we take our train prediction and measure it against the what we were predicting. And that will give us the accuracy of our model. So here it should be 0 because we want our train prediction and our train set that we literally fit the model to be basically perfect. And then our validation prediction and our validation set is doing pretty good. We want the closer to 0 that your answer is, the more accurate it is. But you also need to take into account generalization and overfitting and stuff like that. So now that we have our model created, we want to create the predictions CSV to submit. And so the way to do this is you basically want to just make a submission data frame, set that to the test data frame, because that's full of our predictions that we have. Here, I just wanted to force the order of the columns because in our submission CSV, this is the order that they want us to have it in. And so then you just put in the columns that you want it to, with your predictions, and set that. And then you want to add your index. So then you'll create a new column called forecast ID and set that to the indexes. And then just force the order in which you're going to be making it. Yeah, and so if you want to take a look at how your predictions look before, this is basically it. And it should look similar to the submission sample that it gave you, with the forecast, the number of deaths, the number of confirmed cases and recovered, which it does, so that's good. And so now we have our prediction CSV, and you just run that. And then to submit to the competition, you basically just want to save and run all and commit it. And then once you're done that, which takes a little while, I guess we gotta wait. But basically, you're just gonna go to the viewer, and then, oh, it's not loaded yet. My internet's a little slow. There we go. Okay, so then we go to the viewer, and we want to go all the way down to the output. And we can either submit it like this, or you can download it and then go to the Kaggle Competition page and submit it that way. This way is the easiest. I'll do it both ways though. So you just click submit, and then you select the notebook that you want to use, which is the one that I chose, and then just press submit. And then you can view your submissions. And if it's successful, then it'll tell you your score, which is, yeah. So that's basically all I have to share today. Are there any questions at all? No, I don't think so. All right, Kyle, do you have anything else to add?
Oh, there was a few questions. I think Darren answered them in chat, but I could say the first one. So is this notebook template going to be given to the audience?
Yes, I'll actually be putting it in the tab that I talked about, the notebooks tab. Awesome. So that other people can copy and share it, and yeah.
Yeah, and then the next question was, is there a link to this basic model? But I think that answered that.
Yeah.
And then I think that was the only questions. that we have right now, but feel free to submit more questions. Yeah.
Could I help on it? So, so pretty much, you guys are probably wondering where do I go? Where do I go next in terms of trying to improve kind of my score? So pretty much, I would try to basically you have three variables that you're trying to kind of optimize. What I mean by optimize is trying to kind of get the best performance out, trying to have the truest, well, closest prediction that's closest to the actual thing. So maybe you kind of want to start at maybe one variable and trying to see potentially kind of trying to do Google searches of terms of what kind of feature engineering techniques can I use to try to kind of optimizing my kind of model performance. And also there's one thing is like the features itself that you generate, but then what about the model that you can use? So definitely there's a lot of models that you can choose from. So definitely there's the good and bad parts because each model kind of assumes some kind of thing, and that kind of assumption may lead you towards your goal or may not lead you towards the goal. So definitely maybe try to kind of Google search maybe kind of common known models that are used for time series forecasting, and it also kind of time series forecasting features that are kind of specific. So on October 25th, we'll definitely dive into kind of feature engineering techniques that you guys can use to try to improve better scores. And yeah, so if anyone has any question, feel free to either go to the discussion or ask on Discord, and I'll be happy to help. And definitely try to get creative because I think as a data science or a machine learning expert, you definitely want to be creative in terms of what kind of features you generate in general and maybe in models. And yeah, that's pretty much it.
That was great. Thank you.
All right.
We just got another question from Forrest. He said he loves the idea of open notebooks, but how will this work in a competitive format? Will others be able to see my technique if I'm closer to the top? Does Amaya want to answer or Darren?
I guess oh, go ahead.
No, you know, fine.
So definitely, you definitely do not want to share your notebook in the competitive advantage. But definitely, so definitely, I think each notebook has like two settings in terms of whether it's public or private. So definitely want to make sure it's private so people don't know and people can kind of see your work. Also, you also want to share if you have a partner or not, and we can definitely help if you're kind of unsure whether your kind of notebook is public or private. And yeah, so definitely maybe if you want to kind of put a challenge on yourself, you may want to release your notebook. Hey guys, here's my notebook. Do whatever. I'm just gonna try to get better at it. But have fun, and yeah.
Awesome. Really quickly, I'm just going to take over presenter for a second. So in, I think, 2 weeks, so October 25th, in 3 weeks, my bad, we have a feature engineering techniques workshop. So feel free to sign up for that. Registration is open. I feel like that workshop will be pretty useful for this competition. And then I'm just going to check if there's any other questions. Oh, did I not share? Oh, so annoying. Teams. Every once in a while doesn't work. Here we go. Yeah, so our feature engineering techniques workshop. So it is October 25th, same time, 6 p.m. And it's a Sunday again, just in 3 weeks. Let's see. So we just got another question. It's, can you upload other notebooks like from Jupyter onto Kaggle? So Kaggle uses Jupyter, so you are good there. You would just have to make your notebook on Kaggle. So your notebooks have to be submitted through Kaggle. Yeah. Oh, another question. Forrest asked a great question again. Love his questions. I was watching at 2x speed, but there's a lot of data science ideas that happened really quickly. It was a big step up from last week's workshop. How can I get up to speed fast?
I guess I'll give my kind of point of view, and then maybe Amaya can give her kind of point of view. I think kind of reading about the topic of data science definitely gives you like a heads up. Definitely kind of researching kind of common techniques that they do. For me, YouTube is a big thing. Definitely Kaggle, they have their own like YouTube channel where they kind of present like a lot of ideas in terms of kind of innovative techniques or models. Um, so there was this one interesting kind of video I watched was like the key to winning Kaggle competition, and there was kind of two steps. There's one, the features that you kind of generate, kind of give your models a predictive kind of power in terms of the how close will you be to the actual kind of reality of things, and then also what kind of model do you choose. So definitely depending on a certain type of problem, some models are preferred other than some. So maybe potentially a neural network, but then you want to see what kind of assumptions that a neural network make and where does it fail at. So definitely a neural network for this in this case, because since we're dealing with time series data, may not be the best thing. So one thing you may want to look at is LSTMs, which is long-term short-term memory neural networks, and these kind of neural networks, they kind of encode that kind of sequence to sequence kind of data that you want to kind of your model to know about in order to kind of predict. And yeah, that's what I have. If Amaya has anything to share, you can go ahead, but yeah.
Yeah, I think those are some good places to start. Also, if you're like super, super new, Kaggle offers a bunch of different courses that you can take. So there's like an introduction to machine learning and everything like that. Google also has a few courses if you like more hands-on learning instead of like watching videos or reading. That's how I like to do it. So yeah, just look for some courses because those are super helpful, I found.
Awesome. I think also next week is our maximum likelihood estimate workshop, which is going to be great. But we also should have one more event coming up that's a bit more of an introduction. It is not up on the website yet. Of course not. That sounds about right. So that should be in a few weeks' time, where we'll have a bit more of an introduction. What's it called? Event. Let's see, is there any other questions? Someone asked where would be the best place to find public COVID data sets?
I think one of a good place to start is just Kaggle, but you definitely want to kind of think about what kind of data you want to put in. So since we're dealing with provinces, Canadian provinces, so another kind of source would be like StatsCan, and anything that has to do with maybe potentially you want to think about what kind of variables can affect in terms of the number of cases, the number of deaths, and number of recoveries, potentially the temperature. I don't know. What else? Maybe kind of the population, but then you also have to think about what kind of model you're using for when you are kind of using and when you're kind of ingesting this data. And yeah, and that's pretty much it. What I have up in mind, definitely, if if you guys find something that's cool, definitely try to share amongst other people. Maybe not. Maybe that's your competitive advantage. But definitely have fun with it. If you guys need help in terms of, hey, I need to kind of merge my data set, definitely reach out to Discord and I'll be happy to help. And I think the key here is maybe try to find things that are day to day, or since the dates are pretty much daily, but it can be hard. So maybe monthly, anything that would help kind of boost your power. And definitely it's a trial and error kind of process. You may be thinking, oh, this thing can potentially help me improve my model, but it doesn't work. So definitely, I think that's kind of a life of a data scientist. It's a try and error, and definitely some things work, some things do, and just have to try it out.
Awesome. Someone asked, where can they find the Google intro videos for data science? I'm assuming you can just Google that, but maybe they were having trouble finding that.
Yeah, I can link them in the Discord later, like after this ends. I'll just put it in the general chat on Discord.
Awesome. I don't see any more questions coming in, but maybe we'll wait a minute or two before we call it a evening. Just a reminder that we will post this event online to our YouTube in a couple hours once it's uploaded and ready. And if you have any questions, our Discord's always open, and you can feel free to also post on our Kaggle Competition page or reach out on any of our social medias for help and advice. Yeah, I guess we'll just wait a few more minutes for any other questions coming in last minute and go from there. David mentioned that the Google Machine Learning Crash Course is a course, I guess, that you could take. Awesome. Okay, I think that's going to be the end of questions for now. I myself will hop on Discord in a few minutes and just chill out there for probably 10 to 15 minutes before I head off. Amaya, Darren, are you also able to hop on Discord after this event?
Yeah, for sure.
Definitely.
Awesome. Okay, well, thank you so much for attending, everyone who's here. If you have any questions, feel free to reach out on Discord or post in Kaggle or wherever you're comfortable posting. And then I guess we'll hop on Discord in a few minutes. So thank you so much, everyone, and have a great rest of your evening.